Dear friends, in this class, first let us discuss about the inverse of Euler function. So, inverse of Euler function means we have phi equals mu star n. Phi equals mu star n. What is mu star n? Then phi equals sigma over d divides n mu of d into n of n by d. So mu of d into n of n by d, that is mu of d into n by d. So phi equals mu star n. Phi equals sigma over d divides n mu of d into n by d. Okay, mu of d into n by d. So phi is mu star. So what about a phi inverse? Phi inverse equals it is mu inverse star n inverse. Phi inverse is mu inverse star n inverse. But what is n? N is a completely multiplicative function. N is completely multiplicative function. Since n is completely multiplicative, we have what is n inverse of n? N inverse of n equals mu of n into n of n. By the previous theorem, if f is a completely multiplicative function, then f inverse of n equals f of mu of n into f of n. So by that argument, n inverse n equals mu of n into n of n. Therefore, what is phi inverse? Phi inverse equals mu inverse star n inverse, that is mu inverse star. What is n inverse? N inverse is mu n. Agreed. N inverse n equals mu of n into n of n. That means n inverse equals mu n. So it is phi inverse equals mu inverse star mu of n. But what is mu inverse? Mu and u are Dirichlet inverse of each other, means mu inverse equals u. So we have phi inverse equals u star mu of n. Mu star mu n. U star mu n. U star mu n means since star is commutative, it is mu n star u. What is mu n star u? Mu n star u means sigma d divides n mu n of n into u of n by d. So mu n of d into mu of n by d. So mu n of d into d of u of n by d. What is mu of n by d? That is sigma d divides n. It is mu d n d. What is u of n by d? U of n by d means 1. Agree? U of n by d, u of n by d from here. That equals sigma over d divides n mu of d into what is n of d? D, and u of n by d is 1. So finally phi inverse equals sigma over d divides n d into mu of d. So this is the inverse of Euler function. So the inverse of Euler function is phi inverse equals mu inverse star n inverse. Finally it is sigma d divides n d mu of d. It is sigma over d divides n d into mu of d. So this is phi inverse n means inverse of Euler function. Enough. Now let us consider another theorem. If f is multiplicative, there is a theorem. If f is multiplicative, then we have sigma d divides n mu d into f of d. Sigma d divides n mu d into f of d equals products p divides n. Products p divides n 1 minus f of p. Products p divides n 1 minus f of p. If f is multiplicative, then sigma over d divides n mu of d into f of d equals products p divides n 1 minus f of p. The theorem is important. So how its proof is? Come to the proof. So first we define, let g of n equals sigma over d divides n mu d into f of d. That g of n equals sigma over d divides n mu d into f of d. But what is g? G is multiplicative. It is given, since f is multiplicative, then let g of n equals sigma over d divides n mu d into f of d. Then we prove that g is multiplicative. G is multiplicative. How? This is the first part. When you define g of n equals sigma d divides n mu of d f of d, then to prove g is multiplicative. How? For that, let m and n are positive integers with m and n are relatively primes. Then what is g of mn? We have to show that g of mn equals g of m into g of n. What is g of mn? According to this construction, sigma over d divides mn mu of d into f of d. Sigma over d divides mn mu of d into f of d. But what is d? Here the divisor d is of the form ab. Here the divisor d is of the form ab, such that a divides m and b divides n with a and b are relatively primes. Thus the sum becomes g of mn equals sigma over ab divides mn. Sigma over ab divides mn mu of d, means d is of the form ab with a divides m and b divides n, with a and b are relatively prime, so it is mu of ab into f of ab. That equals sigma over a divides m, b divides n. What is mu of ab? Mu is a multiplicative function, so it is mu of a into mu of b. It is given f is multiplicative, so f of ab equals f of a into f of b, with a and b are relatively prime. Then you can rearrange it as sigma over a divides m mu of a into f of a into sigma over b divides n mu of b into g of b. So this is nothing but g of m. Sigma over a divides m mu of a into f of a is g of m, and the second one is g of n. So finally g of mn equals g of m into g of n. Hence g is multiplicative. So that is the first requirement. When we define g of n equals sigma over d divides n mu of d into f of d, and it is given f is a multiplicative function. Moreover, we know that mu is multiplicative. Then by using that arguments, we can immediately conclude that the g is also a multiplicative function. Now let n equals, now we define, let n equals product p divides n. Let n equals product p divides n p power a. N equals product p divides n p power a. Therefore, what is g of n? G of n equals product g of n equals g of n equals g of product p divides n p power a. It can be rewritten as, that is same as product p divides n g of p power a. Since g is, we know that, or we already saw that g is multiplicative. Hence, when n equals product p divides n p power a, by the multiplicity of g, we can argue that g of n equals sigma over p divides n g of p power a. But what is actually g of p power a? But g of p power a, come to the definition of or construction of g. G of p power a equals sigma over d divides p power a mu of p into, as mu of d into f of sigma over d divides p power a mu of d into f of p. That means g of p power a equals, the first part is when mu of 1 into f of 1, p power a, the first divisor of p power a is 1, plus the second divisor of p power a is p, since p is a not prime, so it is mu of p into f of p, plus the third divisor of p power a is p square, that is, it is mu of p square into f of p square, plus etc. So come to the third term, mu of p square into f of p square. P square, mu of p square, it is a prime square term, so mu of p square is 0, mu of p cube is 0, mu of p power 4 is 0, all the term except the first two reduces to 0. So this is mu of 1 into f of 1. What is mu of 1? That is 1. What is f of 1? Since f is multiplicative, we know that when f is multiplicative, f of 1 is 1. So it is again 1. So it is 1 into 1 plus what is mu of p? Mu of p is minus 1. Mu of p is minus 1. So minus 1 into f of p equals 1 minus f of p. So g of p power a equals 1 minus f of p. G of p power a is 1 minus f of p. But what is n? So g of n equals product p divides n g of p power a. Therefore, from this we have g of n equals product p divides n. G of p power a means 1 minus f of p. So that is what we reduce here. So sigma g of n equals sigma over p divides n 1 minus f of p. But actually what is g of n? G of n is sigma over d divides n mu of d into f of d. Then we show that sigma over d divides n mu of d into f of d equals product p divides n 1 minus product p divides n 1 minus f of p. That is what we reduce here. Okay. So when f is multiplicative, then sigma over d divides n mu of d into f of d is product p divides n 1 minus f of p. Okay. Now, by using this result, that is when f is multiplicative, then sigma over d divides n mu of d into f of d equals product p divides n 1 minus f of p. What is phi inverse? We have phi inverse equals inverse of Euler function. Phi inverse equals, we already proved that sigma, it is sigma over d divides n d into mu of d. Sigma over d divides n d into mu of d. Sigma over d divides n d into mu of d. So this can be, that means phi inverse equals sigma over d divides n mu of d into, what is this d? D can be rewritten as it is n of d. Sigma over d divides n mu d into n by d. So by definition, by this theorem, when f is multiplicative, sigma over d divides n mu d of d equals sigma over, product p divides n 1 minus f of d. Here we know that, here when n is multiplicative, as well we know that n is multiplicative. So according to this argument, sigma over d divides n mu d into n by d is product p divides n 1 minus n of p. So that means phi inverse equals product p divides n 1 minus n of p. Why? Because of this argument. When f is multiplicative, we have sigma d divides n mu d f of d equals product p divides n 1 minus f of p. Here phi, we know that phi inverse is sigma over d divides n mu d into n by d, but clearly n is multiplicative, thus we know that phi inverse equals product p divides n 1 minus n of p. But what is n of p? N of p is p. So means, phi inverse equals product p divides n 1 minus p. So this is the next result. The inverse of Mobius function, the inverse of Euler function. Inverse of Euler function is, we have phi inverse equals mu inverse star n inverse. Moreover, phi inverse equals sigma d divides n d into mu of d. Again, we reduce this result by using this theorem. We have phi inverse equals product p divides n 1 minus p. So these are the important results. The inverse of Euler function, phi inverse is sigma over d divides n d into mu of d. Again, phi inverse equals product p divides n 1 minus p, where p being prime. Now, let us consider another arithmetic function, which is known as Liouville's function. It is known as Liouville's function, denoted by lambda. Liouville's function. So Liouville's function is defined as, we have lambda 1 equals 1. It is defined as Liouville's function, its definition. So it is defined as lambda 1 equals 1. And if n equals p1 power a1, p1 power a1, etc., pk power ak, where pi's are primes, then lambda of n, lambda n equals minus 1 power a1 plus etc. plus a. Lambda n equals minus 1 power a1 plus etc. plus a. So this is Liouville's function. So for what about lambda 9? Lambda of 9. What is 9? 9 means, yes, lambda 9, 3 square. 3 square. So lambda 9 means lambda of 3 square. What is lambda of 3 square? Minus 1 power 2, that is 1. Agreed? Yes. So what about lambda of 30? Lambda 30. What is 30? 30 means it is 2 into 3 into 5. Means 2 power 1, 3 power 1, 5 power 1. Agreed? So it is minus 1 power 1 plus 1 equals minus 1 cube means minus 1. Enough. What is lambda of 360? Lambda of 360. 360 can be rewritten as 2 cube. What is 360? It is 2 cube, 3 square, 5. 2 cube, 3 square, 5. So it is. So what is lambda? That equals minus 1 power. Lambda of, if n equals 31. So minus 1 power 3 plus 2 plus 1. So equals 1. Minus 1 power 6. That is 1. So this is the Liouville's function. It is defined as, denoted by lambda n, and is defined as lambda 1 equals 1. And when n is p1 power a1 etc. pk power ak, then lambda n is minus 1 power a1 plus etc. plus ak. Then is lambda completely multiplicative? What about is lambda completely multiplicative? Choose m equals some p1 power a1 etc. pk power ak, and n equals some q1 power b1 etc. qr power br. Qr power. What is mn? The product mn equals p1 power a1 etc. pk power ak into q1 power b1 etc. qr power br. So what is lambda mn? By definition, it is lambda mn equals minus 1 power a1 plus etc. plus ak plus b1 plus etc. plus br. There is nothing but minus 1 power a1 plus etc. plus ak plus into minus 1 power b1 plus etc. plus br. Okay, what is actually this one? This is lambda m. Why? Because m is chosen as p1 power a1 etc. pk power ak. So lambda m is minus 1 power a1 plus etc. plus ak into whatever the second term, it is lambda m. So lambda mn equals lambda m into lambda n. For all m and n means lambda is completely multiplicative. The Liouville's function lambda is completely multiplicative. It is multiplicative. It is completely multiplicative. Agree? So by using this definition, we prove a result. Consider a theorem. For every n greater than or equals 1, for every n greater than or equals 1, we have sigma d divided cn, sigma over d divided cn f of d equals 0 when n is a square. If n is a square, 1 otherwise. 1 otherwise. Now also we prove that lambda inverse of n, lambda inverse of n equals modulus of mu of n. Lambda inverse of n equals modulus of mu of n for all n. Lambda inverse means inverse of Liouville's function. Mu is Mobius function. So the inverse of Liouville's function is expressed in terms of Mobius function like this. Lambda inverse of n equals modulus of mu of n. So how to prove? This proof depends upon the definition of this Liouville's function, and by using the property that Liouville's function is completely multiplicative. So the proof is done in the next class.